Hello, friends. It's good to have you here today to have a discussion about a systematic literature review and data analytics with her. Uh, it's your friend, I remain the same, Michael Awole, PhD. Uh, I'm the Senior Research Associate at the College of Business and Economics, the University of Johannesburg. I also double as a Senior Research Fellow at the Buffalo University African Institute for Science, Policy, and Innovation. So we're going to look at this today as we go. Thank you. Happy listening.
So, if you so this is the first slide here. I'm going to be talking about this is the outline that we have for the presentation. I'm going to be talking about the concept of systematic literature review. We want to see the process of the SLR as well. We also want to see text mining
Mining,
and the
analytics.
analytics procedure. Then we want to look at sources of unstructured data sets. This is where the good mine is. Um, Today we actually plan to harvest and to analyze articles for literature review. But I can also tell us there are tons of other activities you can carry out with this are even with this same code that I've shared with us. So we're also going to see what we refer to as document term matrix, and we're going to see some visualization. So and after which we'll then be fine. Please, once I spend 15 to first 15 minutes, please alert me so that I switch to the next. Power of producing right information. The essence of doing all of this, doing our analytics, doing all the things we want to do in R, to harvest data, to do so many things, is to be able to provide right information to the right set of people, maybe for policy making or for decision making in organization. Okay, so that's fine. So the this is not the way you handle your analytics will not be dependent on what you are going to get from here, whether you're going to get quality information or whether you're going to get misinformed information. And I think as researchers, you don't want to misinform decision makers. So that's why we want to ensure that we do it well as we go along. So the concept of systematic literature review is a systematic research or process. Or when we say systematic, it's a form of scientific process. We are not just taking it arbitrarily, one step after the other. You have to finish one step and ensure that you are done with that before you go to the next. So, it's a review of comprehensive, structured, and methodical approach to synthesizing research. And if you look at that, it is comprehensive. Comprehensive indeed. That's why some of the time I advise that systematic literature review, you cannot be a single author or SLR. You cannot see it because it's laborious. You can't do it alone. You have to work with people, with yeah, so the process of synthesizing or systematic literature review, this is like a summary of that. Today we're not talking about what are the things that when you are doing identification, what do you do, search term and all of that. This is not the business for this guy today. But I just like us to see that the first thing you do is systematic literature review is to identify the papers you want to work on, to also do so many things that we have talked about in the previous interaction. And then the next thing is to appraise them using inclusion and exclusion criteria. That's what we're going to talk about here today. But the main thing we want to talk about here today is synthesizing, the aspect where you want to synthesize all the data you have got. And then there are two aspects to that. We have the content analysis and we have the meta analysis, metadata analysis. So that means R is wearing two caps. It can carry out both the qualitative analysis and the quantitative analysis. Most of the time, what most of us talk about is just the content analysis, which is what we're going to deal with today. But I can also tell you that this is another gold mine that most people are not also giving cognizance because you can also extract from quantitative outlets or quantitative articles, for example. When you want to do meta-analysis, every article you want to harvest, one of your exclusion criteria must be that if it is not a quantitative study, you won't include it in this. So this can also extract meta-analysis for us, forest plot, meta-regression. But today, we're not dealing with this. If we have another opportunity, we're going to be talking about this. And it's another good one. But today, this is where we're going to cover. We're going to be talking about the content analysis, which is qualitative study. Normally, qualitative, we analyze using NVivo, Atlas, and all of that, which are not free. You have to pay license every year. But R has provided open source for us to be able to do it well and to even automate a number of processes that you would normally, be filling by yourself and be doing so many categorization. So, how are you going to do thematic analysis for us? So, the next thing now is to see the process of text mining. There are a number of processes which have been summarized as we have here. Your text mining process involves your collection of data. After you've already gathered your data, you begin to process the data. Cleaning, this is where the main thing is. If you are lazy, you just say, let me just clean it a bit and then I move on to do my analysis. It is in computer, we call something GIGO, garbage in, garbage out. If you don't clean, you can spend more than 1 week cleaning, and yet you are still not satisfied. Because by the time you are cleaning and you have your output, you can still see some things that you don't expect to be included in your word cloud, for example. And I have to remove this. You remove that again. You recompose. That's why this is modeling. You can iterate it a number of times. It's not going to cost you. Nobody's going to charge you. It is not like your peers go MTA. You can do that as many times as possible. So these are the processes. And then before the processes, what is unstructured textual data? If I go to Facebook and we are reading about how Trump won the election, you want to put a comment. She also wants to put a comment. You also want to put a comment, you want to also add his own comments. All those comments are not likely to be the same. It depends on the way you are looking at your own perspective of that. That's the mind you're going to drop there. So, those tests, the way they are presented, maybe at the end of the day, you only submitted like 100 words, 50 words, 20 words, 30 words. They are scattered, they are not organized. So, but at the end of the day, the process in R will assist you to bring them together, to structure the unstructured first. So the first step is tokenization, to break the text into smaller units like words. You have a complete article. Normally, when you want to write article, they give you don't write more than 8,500 words. So all those 8,500 words of that article will be broken into that pieces. If it is more, it's going to break it into that pieces. That's the process of tokenization. Then it's also going to lower the cases. Some of the things you capitalize at the beginning, you do small letters somewhere, all of that will collapse everything to small letters. Then to also remove stop words like the involvement of something. D is not useful. It is not a keyword. Of is not useful. It is not a keyword. And it's just a conjunction. It's not a keyword. So it's going to remove all of those because they cannot be part of what you really do. Then the next one is stemming and lemmatization. This will reduce your words to their root form. Running, runs, if there's anything like that. Runner, it will truncate runner to run. What is the action word in runner, in runs, in running? The verb there is run. So to truncate everything to the root word, this is what this procedure will do. And all of these ones are models, that will be activated, or packages that will be activated to do each of these. Then the next one is to remove the noise. Eliminate comma. Normally when you are reading, and you are reading, in the beginning God created the heaven and the earth was without form and void. So woman, you can't understand. But when it's in the beginning, God created the heaven and the earth, another comma is better for you. But for machine, it does not make any meaning to me. All those command and full stop, they don't add to your things. So it will remove all of that. Then the next thing is text normalization. Also normalize your text by handling synonyms and correcting spelling errors. So the next thing now is all of these things I'm talking about here, we are going to practicalize. So unstructured text, like I said, I think I defined it there. You can see it. They all scatter everywhere. But today we're going to be bringing our unstructured text from academic papers. But these are other sources where you can get your text from or your data set from. You can get them from emails, meeting transcripts, like we are meeting here now. All the things that I'm saying, if somebody is recording, you can go back and transcribe it and then have it as text. And that way you can analyze. So also if you go out to carry out interviews for your respondents, you go to one respondent, you tape record. You go to another, you tape record, and then you have over 20 of that. When you get back, you can transcribe. Once you transcribe interview V1, you label that interview V2, 3, 4, up to 20. So all of those will represent our papers 1 to 10, like I said. Each of those ones will bring them together as well. Also tweets. Tweets on a particular thing. Maybe which keyword now we look at for? Tweets. Normally in tweets, we use hashtags. One of the essence of the hashtags is to be able to collate all the discussions within that hashtag. Take, for example, we are discussing about, do we say, we are used to hiking pump price in Nigeria, so that's what came to my mind. I don't know. Which one do we talk about? Climate change, fantastic. Okay, I currently wrote a paper on that. I have it in public place. You can also download it. It will also give you, maybe about climate change. I'm sure our engineer would like that. He's an energy man. Climate change, hashtag climate change. Anything on hashtag climate change, when you search for that in Twitter, it will bring all the discussions throughout the world to your desk. And there's a procedure in HARO that can harvest all of that for you. Apart from the sample that I used there, I've also harvested over 1,000,000 tweets for analysis before. You can handle all of that. So these are some of the places, Facebook, different maybe reviews of products. You want to know what people are saying about your products. If you are representing an organization about this particular product, you want to know what they're talking about. You harvest and you analyze. This same code can do the same for all of these sources with a little tweak. So these are some of the things. That people will say that, it's because I don't have data, that's why I cannot write articles. It's not true. Because they are there free of charge for us. So I move on. So the next one is document term matrix. The procedure will translate all our words, all the data we have gathered into this format. If you look at this format, this is like a matrix, is that not? Column, rows, and column. We have our rows. We have our rows this way, representing document 1. That's article 1, paper 1. We have document 2, another paper 2. Document 3 up to document 6. Now we have the terms that have been separated. The terms are the words in your articles that you have seen. And all of these guys you are looking at here, these figures, are the number of frequency each of those terms exist in the document. Document 1, article 1. How many times does the word term 1 exist? 3 times. You understand it better when I go to the next slide. This is still the same document term matrix I was talking about. Somebody online, I don't know, you should mute everybody. And this is paper 1. This is one of your papers you have downloaded for analysis. And these are some of the keywords in that paper 1. What do we have here? Innovation and development, the role of adoption of our technologies in what? In Africa. But before you do your DTM, you ought to have done what? Treated removal of words. Of what? Removal of what? Stop words. Stop words and the of, in. You don't need all of that. And then what again? Punctuations ought to have gone. Is that not? So the only words remaining here will be the keywords, which are what? Innovation, development, role, adoption, firearm, technologies. But why is it giving us technology? Don't forget I told you, lemmatization. It will reduce it to the root word. Lemmatization has also occurred on it before translating them to tables. So we have technology, technologies, technological. It will truncate them to the word technology. So that's what we have. Then Africa. So when the computer picks your paper one, it will check how many times does innovation exist? One time. Paper two, how many times development exists? One time. How many times does adoption exist? One time. Okay, fine. Let's go to paper two. It is not you that will be doing that. That's what the computer will do. You know, paper two, okay, fine. How many times does development exist? Oh, paper two, development three. So that means innovation does not exist at all. That's zero. It's represented by zero. Paper three, development three times. Role one time. I mean two times exactly. Technology one time, and the rest zero zero. So these are some of the things. This is the main thing the system will use to know how important each of those keywords are. Because at the end of the day, another procedure, which we call row sum, it will sum everything together from left to right. There'll be another column to look at the summation from left to right. Oh, anyone with zero entry will be the least. 15, thank you. I'm moving on. Thank you so much. Anyone with zero entry, that's the least. There will be some that will be like, say, 55. Another one 100, another one 20, another one 30. So that will show how important each of those words are, and the documents also as well. That's what it's going to use. So by the time we go to the procedures that will be carried out of this, it will be very simple. You won't have any need to be asking questions about, oh, what is this one doing? You can see it at a glance. So these are some of the visualizations we are going to begin to ask with. The word cloud. And if you look at the word cloud, how do they generate this for you? The more important they are, the bigger the terms. So from here you can see very vividly that data, very important, is key. Technology is key, study is key, base is key, analysis is key, industry is key, model is key, education is key, and so on and so forth. Even correlation is also key. But you already know that correlation is not part of the word that should be part of this. So you mark this out, you pen it down for what? For the moment. Because you have to go back again. That's why I said it's iteration. You do it as many times as possible until you are satisfied. So you have to note that this correlation is not part. How 10 is not what I want. You note it down. You move that because all other colleagues are not there. Cape Town is not there. Liverpool is not there. So remove this. You have to pen that down. Type. It does not make any meaning. This is the type. You don't type of what? Maybe it's not part of what I need. Depending on what you want to carry out. If it is part of what you want to carry out, you leave it out. And a number of other things like that. Road is important because we are talking about using fire-hard technologies for road transportation. So road is important. You leave that. And a number of other things. CRC, colorectal cancer is important. It's part of the research. We leave it out. Cloud computing. These are some of the technologies. Internet of things. Okay, that's fine. So that will give you a glimpse of the terms that exist within your documents. And then to what you want to do at the end of the day is also, divide those words. Look for related words. Let them come together. We call that classification or clustering. You want those that relate to one another to come together. But then, how do you then know how many clusters can I perform? You can inspect it using this. I just say, okay, give me 17. Let's see what we have. This is 17 clusters. Look at it from this place to this place. That is showing the impact. The impact, showing that there is the impact is huge between this first one and the second one. This first cluster, second cluster. So that means this guy is contributing more. This cluster is contributing more to the discourse. And then this is also contributing. This is also contributing. This is also contributing. You can see that it's almost same level from here. You can see the distance between this and this is almost same. So you can truncate it at, say, well, okay, 1, 2, 3, 4, 5. This is different. 5, maybe 6, and then you can have the cost point here. You don't want this, so try 6 clusters. So, and then so if you look at it, you can see main. When we are programming, you are going to be seeing main is equal to this. If you want to give it heading, your graph, you want to give it heading. So say main. Then this is y lab. This is y axis. We know now. Don't work what you say y lab. This is x axis. So when you want to, whatever you want to write in x axis, you put it in x lab. The same thing there, and so on and so forth. Okay, I move. And then you generate your latent tips. Since I've already said, okay, give me 6 clusters. It will classify those words into 6 clusters of these terms. You can also change the number of words. 1, 2, 3, 4, 5, I have 15 here. That can be represented. You can put 10, you can put 20, depending on what you want. So if I have 15 here, 15 in 6 places, that's how many words? That's 60. That means this cluster is only taking cognizance of 16 top terms, which I think is enough if you are just doing small projects, to represent all your terms. You can also decide to do whatever you like and move on. We're going to be seeing all of that. So, okay, so this is where we're going to end here, and then we'll go to the practical session where we're going to demonstrate all these things we have been talking about. I would see if I can share that. Do I stop sharing or I should just go to, let me see. Okay, so I go to the practical session now where we're going to. Can you see that screen? The R screen. Fantastic. Okay, if you're online, as you are seeing the R screen, that's good. So what we're going to do now is, I've already said that people, this class apparently, it is not to teach us how to use R, but it is to demonstrate to us how to use R to carry out analysis using systematic literature review, analysis of systematic literature review. So, but I think about I would ensure that you are able to, I'm able to walk you through about 50 to 60% of the code for you to understand, because it is not a day job. So the rest, I'm hoping you can send your email if you want the codes to be shared with you, so that you can also use that. So the first thing when you get to R environment, this is R Studio environment. It is like the graphic user interface for R. R in itself is not that friendly in terms of usability. But they have created an IDE, which is called R Studio, which will interface you with R in itself. So you now have about 4 quadrants here. If what we have here is the first quadrant, where it's empty, we call this one global environment. The next one here, where I'm hovering my mouse, can you see the hovering of the mouse somewhere? Okay, that's fine. So that's where you're going to be getting your output. If you want to plot graphs, visualizations, this is where you're going to see it. If you also want to do so many other things, this is where you're going to be getting them done. And then in this third quadrant, that's the command line, where you can be typing your codes, typing your commands. And then the next line, here in this place where I'm hovering my mouse, where I've selected some codes, it's where you can begin to type in your codes and be working with your codes. So we're going to start from, then the first thing you do when you get to your R Studio environment is to tell her where you want to be picking your documents from, in terms of the directory or the folder you want to be retrieving your files from, and the folder where you want to save your codes. So you go to session, you click on session, go to set working directory. That will flare out some free options. From there, if you have already opened your code in this place, the next thing is to just click on to source file. You click on source file, and it automatically redirects R to go to the folder where your source file is saved. But if you have not done that, you want to pick the folder, that you already have existing on your computer, you just go to choose directory. You click on choose directory. Once you click, this is very important because otherwise you just find out that even when you are writing code, you want to retrieve your file, the R will not know where to pick the files from. So you click here and you can then go to trace your file. For me, I have my folder here, which is what I normally use. And once you click on that folder, you can see that there's a blue screen in the command line, in this command quadrant, that will display to you where that folder is directed to. So that is that. So that means if I want to key any code down, I must save my file in that same folder. So now let's say I want to open my code now. I want to open my code. Or let's say you just want to create code. You just go to file and new R script. That will give you a fresh page. And here you begin to type your codes. But let's just open the codes that I want to use for the for this. So I go to my file and I open. Okay, I want to open this. I open this now. So I'm going to begin to explain to us one by one. The first thing when you get to R, you want to do after you have set up your working directory. The next thing is there are some packages which you have to load into the memory of the computer. If that package is not installed on your computer, then you cannot reference it, you cannot call it. It's like if somebody is not in your house, you can't call them. So the same way, you have to bring them into your house before you begin to call them and then use the elements that belong to them. So those packages just like packages, when you are talking about packages, it's not just one thing. You have so many things you have put together and then. So if you look at this one now, for the purpose of what we want to do text mining. There is a package called TM, which will be useful for us, which you have to install. TM. I'm going to show us how to install. Then at the same time, you want to be tidying your test. You want to tidy the test. That's what we call tidyverse. It's another package. You don't have to cram them. Don't worry yourself. You don't have to cram them, but you can note them down. So tidyverse. There's another one. Want to also do PDF. Want to call up PDF into the memory. There is a package called PDF tools. It must be installed. Then you also want to do plotting of graphs, of charts, and all of that. There is ggplot too, which is responsible for that. You must bring that on board as well. Okay. Very quickly, because we don't have time.
You have to install them on the arrows to go.
Yes, you have to install them. I'm going to show us how to do it. I just want to notify us about some of those libraries, packages. So you now do install. You can, and once you install once, you don't have to trouble your computer to continue to install again each time you want to run. No. Once you install once, it is there permanently. But the next thing you have to do, anytime you want to use it or you want to run your program, you have to bring them into the memory, into the buffer of the computer. And what do you do to bring them into the buffer of the computer? You type library to bring them into the buffer. But let's see the installation first. If you look at this code, you will say install the packages and then you put PDF tools. But then in inverted, two of them, the package must be in inverted commas. Do you get it? I'm going to do it here in the console. As you are even typing it, R will be assisting you to bring the likely thing you want to type. You see, can you see that? You can easily accept packages. You can see open and close bracket. That's where you type the package, the name of the package. But then that name of the package, because it's coming in character, you have to quote it. Opening quotes, double quotes, and closing quote has to be there. So you type that word there. Let's say PDF tools. PDF tools. I've already installed it, but I want to install again for the purpose of this meeting. So once you click on that, it should install. What does it say? Install packages PDF to depends. Maybe because I've already installed. Okay, let me pick another one. Let me pick consider. I think that is consider. if my spelling is correct. Uh-uh. Consider. Oh, can you try it on your system? Let's see. Let's see. Because you have not installed the PDF tools. Install PDF tools on your system. Just type install dot install. Once you press install dot, it did not do your RStudio. You see, okay. You use this to say RStudio. Type RStudio. Okay. So this is what we're not going to be talking to her. RStudio will be talking to her. So open that web to open it. See, if you're already in RStudio, let me see where you are. If you have RStudio, okay, let me come to you. So, okay, good, like that. No, this is yes, okay. Install. No. Remove all of that. Just type install small letter, not small. See, it's already there. Is already bringing suggestion to you. Pick the second exactly. Now type open and close brackets, open and close bracket for inverted commas, double quotes. Now put PDF tools. Tools. No, all together. Small letters, all together. PDF tools. Press enter. Okay, wait a minute. Okay, do that again. Remove the quotes. Okay, another way to install it. Let's do it. Come go to packages. Click on install and type PDF tools. See, just click on tools. Install. Is it installing? Good. I'm going to demonstrate. You can see that. Please tell the person by your side what to do. So, like I said, I'm going to also demonstrate. If you're having difficulties with that, I don't know why this is giving me that. So, I want to, whenever you see hashtag, anything that follows your hash means you are telling the system that I want to put comments. So, it will skip it when it's running. It is just for your notification. So, I'm going to do that here. I want to run that line. It's saying this is installed, not found. Oh, it's doing it here now. It's doing it here now. So I'm installing my PDF tools now. If I've not installed before, it's installing. Can you see how it's flowing? If you look at that screen, it's installing. The alternative way to install, like I said, I'm going to point our attention to that. You go to the second quadrant here, where you have files, plots, packages, app, and all of that. And you go to packages. Once you click on packages, you click on install. And then from there, you can type the name of the package. So here, let me type consider. Okay, contest. Let's say contest. I just click on that. If it is PDF tools, you type it as well. You click on install, and it will begin installation. Once you see this red button here, it shows the system is still busy. It's still busy. Wait for me. I'm still working. So it's installing. So after the installation, once you have succeeded with the installation of your packages, you can then begin to use it. So how do you then use? We'll go to the next one, which is library. If you look, you use the word library or require to bring it into the memory. So I will click on library PDF tools to bring that particular package into the memory. I also have topic models into the memory. I also have another one, TM, deployer, ggplot for our graphs, tidy test to tidy our test, word cloud for the word cloud. All of those ones are important. So I'm going to run all of these together now, but meanwhile, I'm not going to go back to install. My installer, I'm going to comment it out by putting hash so that I will not reinstall again. I don't have to. So we just go to click all of this library, and then this is still busy installing that particular thing. I have to wait for it. So you are going to click on the, I think it's I've succeeded. Okay, that's fine. So you are going to select all that together and run. Once you select that together, Control Enter is to run, if you like. You can also use your go to the build. Sorry to don't mind me. I like to the codes and look at different types of ways by which you can run run your code. But most of the time for me, I like to select to run the particular session I want to run. So you come to select run here, which is the shortcut is Control Enter. So once you have already loaded that library into your system, then the work will now begin. The work will now begin. If you look at this one now, you want to, this is what I'm highlighting, if you can see it on your screen. This is the line that will bring in all our PDFs, which we must have saved in our folder. So the command, there are two commands. There is one to the left and there is one to the right of an arrow. Something like an arrow, left elbow and one pointing like this. Divide into two. One to the left and one to the right. The one to the right are the commands that you use to the computer. The one to the left is your own word that you have used. Where you want to, it's like when you want to eat now, where do you want your food? You want it in a plate. Some will like it in a takeaway. Is that not? Some will have it in another form. So that's what you are doing. What you want the computer to do on the right hand side, put it in an object or a variable called all PDFs. That is your word. So that by the time you need it again, you are not going to be issuing that command on the right again. You're only going to be referring to the one on the left. So, if you look at the command to the right, it's talking about list files. Pattern is PDF. The list files is, we want to list files that I have in my folder. There is like a list of them. You have, I don't know how many numbers you have in your folder. And I think I said we can have like 5 or 10 or whatever. You can have 200. So if you look for that format that you have specified in the pattern, which is PDF, in that folder, you might have other formats, 5 formats in that folder. You will not reckon with it. It's only reckon with what you have instructed, which is pattern is equal to what? PDF, dollars. And then you put it in inverted comma. That's the pattern. But the only thing here that is the machine word is list.files. The one to your left is your own word, which is all PDF. So once if you click that on that line and you press your Control Enter, can you see something happen very fast to the right here in this first quadrant? You can see that this is created. So if you look at that very closely, after CHR 1 to 49, what do you think that means? That's the total number of my files already uploaded. 49 PDFs. Which is stored where? In all PDF. So if you double click this all PDF, or in the alternative, if it's not doing it, you can select all PDF alone here and run it. All PDF and run it. The list of those documents is will fly down. Do you get? So that means it has already uploaded 49 documents for me here into the memory. But that's not where we're going. We also want to convert all of those PDFs into text. That's what the next line is doing for you here. So like I said, the word to the left is your word, is your coinage, all text. Put all the text in that one. And it's going to use that format, apply, to put the content of your PDFs, all your PDFs, which we have here now. And then it's going to convert them into text using that line. So once you click this, you run this one again. It's going to okay, so it may take some time to load, to run. Yes, mine is ready. If your system is fast enough, Depending on the number of documents you have, it will convert it in a jiffy. Mine is ready as it is. You can now see that in the global environment, all text is also appearing. So if you can click on the arrow here, it will give you the summary of each of those documents up to the number that you have uploaded. In the alternative, you can also come to the command line here and type all text. All, as you are trying to type, it will fly it out for you because it's already, the computer can recognize it. You press enter and it will list all those documents for you. The text format already extracted. Don't worry, it won't bring the pictures, it won't bring the figures, it won't bring the tables. We don't need all of that. It's just show you all the text already harvested, and that's what you have there. So the next thing now is to convert these text, all these text that are already in one single file, that have been collapsed in one single file, to also bring them together in what we call corpus. It will bring them together let them be a family. We want to mix them together, not separating them now. So the next line will do that for you, which is paper corpus. That paper corpus is my coinage, meaning that this is my corpus file for the papers. The one to the left is my own word, but the one to the right are the computer commands, which will now convert. They are the functions that will convert the text, that will collapse the text together. And that's what you have. That's why I said you don't have to cram them, but as you begin to study it yourself again, you understand what they do. That's why I'm taking time to explain what they do. So that by the time you sit down, I can always run this one and then we go to where we are going. But you need to understand it also so that in case you want to tweak anything later. So that is that. So this will convert to the corpus, and if you run that, the corpus is there. Come back to the global environment here again. Our corpus is there. Our right hand side is there. So we'll move on. The corpus, like I said, is all the entire text in one single file, ready for processing. And that entire file is in what name? Is that in what name? Paper corpus. So that's what you're going to be processing. That's the file you're going to be bringing in for processing. Now, so the next processing is to do what? To begin to do cleaning. Cleaning of the contents. The first cleaning we want to do is to convert to what? Lower case. We want to transform all those contents into lower cases. So the command to do it is in text mining package, which you have installed previously. So the paper corpus, you are still maintaining your file name to paper corpus. After I have gone to play football on the muddy field, and I come back and shower, am I still the same Michael or not? I'm still the same. So the same thing is what is happening here. We want the paper corpus is that same corpus, that same file that we want to lower it, lower all the content to lower number, lower character rather. And at the end of the day, we'll put it back in that same container. That's why we are calling it paper corpus again. So when you do this one now, this command now will lower it for you. Will lower all the cases. You may not see it immediately. So the next one is to do what? Is to remove the punctuations. You remove the punctuations that way. You put it back in the same container. Do you now know that what we have now is now different from the original corpus we started with? Is that not? Because it has overwritten the existing one. That's why we are still using the same name, paper corpus, so that it can be updating it. So the next one here is to remove the white spaces. The next one will remove the numbers in the corpus and still put it back in the same container. Then the next one is to also do lemmatization. Like I said, I've explained that to us. Removing the word running into run for all the things. And then to remove stop words, remove the here. There are some keywords that may not be part of what you want to treat with your words. So this is where we are going to list them. You may not know everything from the beginning, but from your search terms, you are expected to remove some key things from your search terms. Because you already know that when you are searching for that particular thing, it should definitely be there. You know, there are some keywords, there are some things you don't want to exist. And then, you know, some of the time you will see authors. On any particular document, they will write author. On any particular document, they will write volume. volume 1, number 1, number 35, sort of that. Normally, there are ways to clean that. There are many ways to clean that, but you can specify it here by typing VOL dot. You may not need to cram it, but by the time you see it in your frequencies, you can then begin to bring them out. I'm going to show us. Okay. So we have done our cleaning, the first stage cleaning here, which will update all our files and still put it in the same paper corpus. So the next thing now is to formulate the matrix table, document matrix that I showed us. That's what it's going to do with this command line. So don't forget, this is what you are treating, that you want to convert to document type matrix. So you want to put it in a container called TTM. That is also your own coinage, the one to your left. So after it has done it, put it in that. It's ready. So you want to see the contents of that DTM. You will just type in the command line, you can type your DTM to see the content. What do you have in our DTM now? An R, excuse me, R is case sensitive. Have you seen? Have you seen that? Do you have that on your screen? I'm going to explain this to us. That's the content of our DTM. It has translated our words into monomeric terms now. Quantifiable terms. Are you okay? You can see that. So I'm going to, because you have to inspect those things, those parameters, they are very important. You need to see them. You need to be able to inspect them and see what they are. Okay, if you look at that very closely, you will see that there are from left to right. How many documents do you have there? Documents is equal to 49 now. Can you see them? Yeah. That means I have 49 documents that are being handled. Then after that is what? Terms. How many terms? Or 14,715 terms. That means that my 49 articles has generated 14,000 terms for me. And then out of then if you look at that, there is non-stroke sparse entries. Non-stroke sparse entries. The entries for the terms now, we now have the non-sparse to be 41,102. Non-sparse. That's the first one. Sparsity means, can I say, words that are not important are the sparse words. I mean, it's talking about that's nothing. It's talking about the distance to the centroid. If I'm going to use that word. It's like, okay, this is the center of gravity. How far are you to this place? If I point my hand here, you can see that she is closer than Benga. You know? So, who is more important to this centroid? Because of the distance between. So, it is the betweenness distance that it will use to calculate the importance of those words. And that's what that is doing. So, if you look at that, you can see that the non-sparse are 41,000 terms. Those are the ones that are not too distant. But what about the sparse terms? How many? You can see the way that thing is written. Non-stroke sparse. Non-sparse and non-sparse stroke sparse entries. So the first one are the non-sparse, which is our target. Those are our friends that we really need to keep. What about the sparse ones? How many? 679,000. Is that not? That's too much. That would water down the quality of our data, of our output. So what we want to do now is to see as much as possible to reduce the sparse words. So what is the percentage of sparsity? That's 94. That's good. That means only 6% of those words are important to us.
On 6.
Yes, only 6%. So, but how to do that is to improve on the sparsity. So I'm going to show us what to do now. If you look at this one, DTM removes sparse terms. You can be looking at the category here. Let's start with 70. This like 70%. This like 70%. Okay. Yes, I've treated that. Let's see what the DTM is going to give us again. What do we have now? Is it getting better? So if you look at the number of terms now that this guy is taking to cognizance, we have 878 terms now. It's becoming sizable, which is okay for me. So it's giving us 878 top terms. That's what this is saying. But with what? How many papers? It has dropped some papers. How many do we have left? 35. Which means some of those papers are sparse. A good number of them have maybe 0, 1 after summing the matches. Maybe they only have one occurrence or non-occurrence at all. It has been moved there. So meaning you are only left with what? 35. But the caveat is this. The more you try to refine it more, the more it will be dropping. It might be dropping your papers that are not that relevant to the context. So it depends on what you want to do. So if you're okay with that, you move on. But look at this again. Look at the non-sparse. How many words do we have? 16,092. Now it has overtaken the sparse words, which is desiring, which is what we want. Look at the sparse words. How many do we have? 14,000. So this is less than the other guy, which is becoming what we want. So look at the percentage. This is now 48%. Well, that means the 52% are the ones that belong to us, that are our target that we're looking at for, the non-sparse. Okay, we can still improve it the more. Let us also go to the remove sparse terms and take this one to 60%. Run that again and try your DTM again. Let's see what we're going to have. Yes, it's improving. How many percent do we have? 39. Can you see that? Which gives us still retaining 35 documents and then 593 words. In fact, if you divide this 593 words, let's say you're going to have like 6 clusters. How many words are you going to have in one? That's 593 divided by 6. Still huge. You don't need that much. Or even if you have 10, whatever, it might still be okay for you. Okay, let's go. Let's try to improve to say 50. So that means what I'm trying to demonstrate, this is not arbitrary. As you are doing it, you have to be inspecting it to get to the optimum, to be sure that, oh, this is what I really want. Okay, so I go on now, and then we'll do the plotting of some of those graphs. Okay? Now this one is improved again. We now have the non-sparse terms now is now about 9,790. When you now compare it with those sparse terms, which is now 4,000, yes, we're getting there. So you are now left with 416 terms. Then you must be very careful. If your number of terms are too few, then you might be chopping up some of the important words. So maybe we should leave it at this, which means when you are reporting, you are going to report 33% sparsity with this number of words. Because so these are some of the things you have to put together in your report. Okay, so we'll move on now. Let's say we are already satisfied with that. So it's going to be taking 416 terms. 416 terms for the next processes. Yes.
Is there a specific percentage for this sparsity?
No, it depends on your data. It depends on what data you have. It all depends on you as a researcher. But the acceptable threshold is about 50%. Or is about the time that your non-sparse is about, yes, the sparse. You get? I already explained that. You begin to be happy or to get to acceptable threshold when the number of terms that are not sparse are greater than the non-sparse. Do you get? So let's move on. So I think that is that. Now we now need to run the next one. Now will now do row sum. Look at this row sum. What is that trying to do? To sum all the entries in documental matrix from left to right for each of the documents. That's what this is going to do. And it's going to check if there are anyone with 0 term will not be captured. That's what all of this will do. Oh, I think I've done this. Okay, that's fine. So I then move to the frequencies. Okay, so let's do frequencies. You want to sum everything now. This one will now do summation of all of that. Like I said, this one will translate our document our words into matrix. That's the translation is happening there. So the frequency here is to count the frequencies, to sum the frequencies. That's what we're going to use this to do. And then the next line here is to do the order of those frequencies, because when you when you get the frequencies, the one with 250 may not be in the same order with another one that is 50. Things like that. But then you want them to be in decreasing order. The highest first, then in decreasing order. That's what the second line of code is doing to order them. So I'm going to now show to check what is the content of that frequency. As you are typing your command line, you want to see the words. Those are the words that are already created. It has already counted the frequencies for each term, the existence of the terms, the number of times they exist in that document. That's what you have here. But the computer will not give you on the screen, you can't see it. But you want to see which one is ahead now, which one is topmost. So you use command head, H-E, in your command prompt to see it. Add frequency. The first 6 will be displayed. Then you now see, ability, followed by able, followed by academic, followed by asset, followed by access, followed by accord. These are the top 6 terms. If you want to look at the last 6 terms also, the list, you type tail to replace that head, frequency. Those are the list terms in this category. Those are the list terms. So that is that. That's just by inspection. Then the next thing now is to print our matrix, which is what this code is doing here. You can see it here. You can see it here. You can see it here. But the next thing now is to now plot that frequency that we have gathered. That's the frequency now that we have gathered. The number of terms is what we have there, and the number of times they exist is what we have here. If you look at this, if you look at our term, let's see. This is telling me battery saver is on. It's okay. Fine. So all right. So if you look at that, those words, okay. Then the next thing now is to also plot we can also do a bar plot here. Can do a bar plot of the words, which also tell you about the frequency of each of them. That's what is displaying here. Like I said, the heading, if you look at those code from left to right, it's saying Y lab is frequency. The main is top frequency, depending on the name you want to put it there. And then where we are really going is to show the word cloud. And this is the code for the word cloud. I'm going to explain that to you. The word cloud here, word cloud is a function. And you have already computed with your words previously before that time, which is this one here, which is what you have done here. So the word cloud will display 1 to 200 words, top terms here. 1 to 200 top terms. It can display 1 to 50, depending on what you want. It can display 1 to 200, 1 to 300, any one of your choice. To experiment, at least you can see. So here, let us see what this is going to give us. That's I'll always like to make it bigger. Okay, you can clear it from here. You can clear all the plots from here to go. And then let's replot it again so that it can be bigger. Okay, that's what we have here. That's what we have. Can you see indeed that datum, data has been converted to datum? What do you think has happened? That's the word of lemmatizing. You know, maybe in those documents we have datum is plural, which is singular. We have data, which is singular, but it's presenting the singular to represent anything along that line. So if you look at it that the word cloud is already generated. So from here, you can inspect the word cloud and be noting the words you want to remove. Once you get the words you want to remove, you go back to remove the environment where we're doing the cleaning. I'll go back there again. That's part of the cleaning, where we used to remove words. Where is it? To the cleaning here. This one. I put abstract air. That's one of the words I wanted to remove. Let's say I can you bring any word you want us to remove? Let's remove that one. Or no, that would be because it has a let's remove development, Abi. Do we remove development? No, it's important though, but we just want to experiment so that we run it again and then you see that you won't find it here again. Development is important, but we only remove words that are not important to the discourse. So but